Hello, everybody. Let's go ahead and get started. I'm going to start the slideshow here. All right. So, heat energy in the atmosphere. All right, so you are going to recognize that the sun provides the energy that drives convection within the atmosphere and oceans, producing winds and ocean currents. So, first, you need to know what is weather, right? The meteorological, I cannot talk today, conditions, temperature, wind, cloud, and precipitation. And we go into more detail about weather throughout the week. So please take notes. You should be taking notes right now. Pay attention to all of your videos and your assignments. So I thought this was pretty cool. It says, so on Monday, there's going to be, a cloud, one cloud in the sky. And then on Tuesday, I guess that same cloud. But then on Wednesday, two other clouds and also a little sun there. So this is your substitute weatherman, because trust me, it doesn't go that way. All right. So weather, it refers to, let me move this. Okay. So weather refers to temperature, amount of moisture, air pressure, wind direction, and wind velocity. Local weather is affected by movement of air masses into the local areas. All right. And we deal with a lot of different changes in weather in Houston all the time. Weather factors. So this is your day-to-day changes in the atmosphere. So you have what is called air pressure. You'll see something that looks like this, kind of give you a little glimpse of what those lines are right there. Those are going to be those air pressure lines. You'll see something similar to this in another unit later on this school year. Okay. Then you have temperature, moisture, and of course, wind. All right. So tools to study the weather. These are just a few things to kind of remember: thermometers, barometer, and hygrometer. So your thermometer, these are the instruments that measures the temperature, right? Then a barometer is an instrument that measures the atmospheric pressure. This is pressure from the weight of the air. All right. And then the hygrometer, it pretty much measures humidity. So where you hear sometimes people say, well, it's 90 degrees outside, but it feels like it's 110, right? It's just that humidity. Okay. So changes in air pressure. These are caused by the difference in air temperature above the earth. Land masses and areas of water change the temperature of the air above them. These changes create wind and cause pressure patterns to develop. The wind moves these pressure patterns that change as they pass over mountains, oceans, and other areas. So, Earth's energy budget, well, we're talking about the sun. So, your incoming is 100% solar energy, right? But notice how it pretty much goes all about all different angles, different areas. For example, 6% is reflected by the atmosphere, 20% reflected by the clouds. 4% is reflected from Earth's surface, right? That's the surface area. Then, of course, you have 51% absorbed by the land and the oceans. Um, let's see here. You have radiated let's kind of get into detail about this. Your clouds and your atmosphere. First of all, once the sun has all of this radiation going into the earth or into the land, you have 51%, but it reflects back, right? It goes back. And notice the increase right here, because as hot air rises, as it rises, that air is hotter. It's not cooler anymore, but it's hotter, okay? Because hot air rises. If you ever been in a two-story home, sometimes the home is warmer on the second floor than it is on the first floor because hot air rises. Okay. So radiant energy from the sun is transformed into heat by absorption at the Earth's surface. The sun's energy is also very, very important. Write this down. The sun's energy is also very, very important in evaporation, the water cycle. You've probably seen this already on your test. You've heard about it in sixth grade. Evaporation is a big, big deal. This is why the ocean is so important, right? The sun and the ocean, they're partners. They work together to create this evaporation for us. So, yes, the sun's energy also powers the water cycle. All right, the angle of the sun's rays affect the heating of Earth's surface, right? At the equator, this is your equator. At the equator, the sun shines directly onto the earth. But notice at the North Pole and the South Pole, it's not going to go directly to the North Pole and South Pole, but you're going to have those angles. So you have like that angle, right? It's an angle. So the North Pole and South Pole is not getting as much heat transfer as the equator because that is where the sun is directly shining. So that is this uneven distribution of heat energy in the atmosphere that causes weather. All right. So then what is wind? You feel wind. Wind is out there. You feel it. You know, it's all on your face or makes you cold or what have you, make you feel good on a good sunny day. What is wind? All right, this is changes in air pressure, brings changes in the weather, and makes winds blow air. Wind is air, air is wind. Air usually moves from the areas of high pressure to areas of low pressure. Remember, high pressure goes toward low pressures, and this produces winds. This can be easily remembered with the phrase winds blow from high to low. Wind facts. Winds move from high to low pressure areas. Now, I think I just said that probably 3 times within 1 minute. So I think you should be writing that down, right? Okay. High pressure is associated with cold air, low pressure with warm air. Say that again. High pressure is associated with cold air, low pressure is associated with warm air. All right. Warm air rises because it is less dense than cold air. Both local and global winds are caused by differences in air pressure due to unequal heating of the air. Air circulation patterns, well, air cools, becomes more dense, and it sinks. Notice how I'm saying just about the same thing over and over again. So I'm hoping that you're writing this down and you're understanding that this is very important, right? Air warms, becomes less dense, and it rises. Okay. When air is heated, it becomes lighter than the surrounding air. Therefore, warm air will rise. Cool air is heavier, more dense, so it is going to sink. The heating of Earth's surface depends on the nature of the surface. Local winds, we talk about the sea breeze, land breeze, and the moon sun. So the land breeze occur on warm, sunny days. Air over the land heats faster than the air over the cool ocean. Warmer air rises. I'm saying that again. Cool air flows cool air flows in under it to fill the area over the land. This air warms and the cycle continues. Then look what happens with sea breeze. Occur at night and on cool days. Air over water maintains an even temperature. Air over land cools, right? Faster. Cooler air flows from the land out under the warmer ocean air. This air warms and the cycle continues. Okay? You need to think about hurricanes. All right? Think about hurricanes, and we're going to get into stuff like that as well. So here are your global winds while talking about those different cells that you have, pretty much talking about that Coriolis effect as well. These are those poster easterlies, your westerlies, your trade winds. And then, of course, you have all of these different cells all the way around. Notice the direction of the cells in the northern hemisphere. The northern hemisphere, they are going in a counterclockwise direction. But notice in the southern hemisphere, they are going in a clockwise direction. So Once again, with that Coriolis effect, the original circulation of air caused by convection is in the north-south direction, but because the Earth turns toward the east, all winds veer from the north to the south direction. The Coriolis force is caused by the differences in velocity of rotation at different latitudes. So when you think about the Coriolis effect, think about a merry-go-round. Think about a merry-go-round. If you were throwing that ball across from someone without the merry-go-round moving, that person will probably catch the ball. But what if you all were turning and you tried to throw it directly to that person? Well, because that person is moving, the ball is continuously going straight, but the illusion of the Coriolis effect is to make it think that it's curving, right? So just please try and remember these different notes and make sure you do the activities. Okay. I have a really good video with people on the merry-go-round, by the way. So you'll like that. All right, and this once again is talking about the rotation of the earth and distribution of land and water area and the exchange of heat between warm and cold areas. We're talking about this all week long, so get used to it. Major wind systems, these are the same winds I was just talking about. Make sure that you understand the Coriolis effect, prevailing westerlies, polar easterlies, trade winds. All of these different winds are a part of your global wind belts, okay? And there's another little illustration. You will need to understand the different components. Notice the doldrums is right here at the equator, okay? Notice your trade winds are right here closest to the equator. They're going toward the equator. The prevailing westerlies are right here between 30 and 60 degrees north, as well as 30 and 60 degrees south. And of course, at each pole, the North and the South Pole, you have the polar easterlies.